Hello my friends! Alright, so today I wish you to have a fantastic workshop. Try to do the maximum of it because this is excellent practice for you. And if you enjoy this workshop, well, join us at cloudwolf.com where we do many more workshops on different applications in cloud computing, especially AWS. Alright, so I'll see you in the workshop, and until then, enjoy the cloud. Okay. So hello everyone, welcome to the live lab number 2 of CloudWolf, which this time will be on Amazon Forecast. Amazon Forecast, which is a machine learning service in AWS that allows you to run predictions on time series. So it is great for all time series analysis problems. And well, today we're gonna solve one time series analysis problem, which is related to demand forecasting. So first, let me explain the case study and the dataset. Let's imagine that we are the general manager of a retail company, and that we have a series of stores, different stores where the same items are sold, okay? And we have the historical data of the sales of each item in each store from 2013 to 2017, and we're going to train a time series prediction model to learn the time series logic from all the days from 2013 to 2017 in order to predict the sales of the next year or the next month. And so, well, I prepared two data for you, the big data and the small data. And first, I'm going to show you the big data because this is actually the original data set. By the way, I want to credit Kaggle where I took the data set. So this is a data set from Kaggle, the Kaggle petitions. This includes many data science projects, including time series analysis. And so let's have a look at the dataset. I'm going to open it with a text editor, and I'm going to show you what this dataset is about. So this is a typical time series dataset where you have the sales of the different items in different stores, the stores of this whole retail company, and at different dates. And so the date goes from 1st of January 2013 up to, if we scroll down, down by keeping the first item of the first store, well, there we go. It goes up to December 31st, 2017. Okay, and as you can see, this is for the first item of the first store. Because indeed, here we have in the second column the store, and in the third column, the item. So basically, in order to sum up in one sentence, this contains the sales of each item in this store and at this particular date. Okay, and let's scroll down all the way down to the dataset to see the size of the dataset. Well, it contains almost 1 million observations, and that's because in total there are 50 items. So there are 50 different items in this dataset in 10 different stores. Okay, that's the last item here, 50, and that's the last store here, 10. And so we have all these sales of all these items in each of these 10 stores from January 1st, 2013 up to December 31st, 2017. And so we're going to train a time series prediction model on all this historical data in order to predict the sales of the next either month or the next year. Okay, that's exactly what we're going to do. However, as you can see, this data set is huge. It's really big. And so training a time series prediction model on this data set would take a lot of time. It would take more than 10 hours actually. And so that's why I've prepared for you another data set, which is the small data. So now from the same text editor, I'm going to open the small data, and I'm going to show you first what I've cut, how I made it smaller. This is the same data, the same sales and everything, but I cut a lot of things. So I'm going to show you, and that's in order for us, of course, to all finish this lab together, and also for the training to not last too long, and also to have the results at the end. Okay, so that's the small data. What did I do inside the small data? Well, first, I changed the format because you have to understand this, that Amazon Forecast doesn't adapt to your data set. You have to adapt to Amazon Forecast. You have to adapt to the format expected by Amazon Forecast. So first, there are different, names of the attributes here, and you will understand a bit later why I had to change the name of the attribute. But also, I cut some things. So what did I do? First, I only kept the year 2017, right? In the big data, the years go from 2013 to 2017. In the small data, I only kept all the days of 2017, meaning from January 1st, 2017 up to December 31st, 2017. And not only that, I only kept 2 items in one store. So as you can see, I removed the store attribute. So I removed the store column, and I only kept 2 items of one store, which is actually the first store here. I only kept the 2 first items of store number 1 here. That's what I did. And then I obtained this small data set. So indeed, if we scroll down the data set, well, we see that we only have the 2 items. Here you see that's still item number 1, item number 1, item number 1. There you go. So you see you have the sales of the item number 1 up to December 31st, 2017. And then it goes to item number 2, still in the same store. And well, we have all the sales of this item number 2 in the same store as item number 1 up to December 31st, 2017. All right? So that's the small data. And of course, we're going to work on this data set in order for us to get the results. I'll get the results at the end. All right. Any questions on the data set? Now is the time to ask any question if you have not fully understood what the data set is about and what we're going to do. So let me go back to you. And is there any question?
No, it's great for me.
Great. Okay. So we can move on to the exciting part then. Now we're all going to go into the AWS console and we're going to build this whole time series prediction model. But first, what do you think we should do very first step before starting to build the model?
Create an S3 bucket.
Exactly, because remember in AWS, when you upload some data, when you're using a service of AWS, whether it is AWS Glue like last time or Amazon Forecast like today, you can't upload the data directly from your machine. You always upload the data from S3, an S3 bucket. And actually, the only service in AWS where you would directly upload the data from your machine is S3. But then, when using any other service, you will upload the data from S3. So that's the very first step. You're absolutely right. Let's go to S3. By the way, I've created a brand new account just an hour ago. I called it CloudWolf Live Labs. And that's from now on the account that we'll use to do the live labs. All right, so let's do this. Let's create a bucket. We click Create Bucket here. And then, well, we can call it whatever you want. I'm going to call it Bucket for Amazon Forecast. And then remember, we all put a random number to make sure the name of the bucket is globally unique. Okay, Bucket for Amazon Forecast, random number, and then we have nothing else to do. We can just scroll down and create the bucket. I'm going to wait for everyone to have the bucket created. Okay, I'm going to continue and stop me anytime you want if I'm going too fast. Okay, so now let's go inside the bucket and let's upload the dataset. So we click Add Files here, and then we go to Small Data and Demand Forecasting. Of course, if you want to play with big data, you can in the future, but for this lab, if you want to do the same as me, I really recommend that you get the small data. So Demand Forecasting CSV in the Small Data folder, open, and upload. Upload succeeded, perfect. Let's close, and now all good for everybody. We're done with S3. Anything we had to do in S3, we're done. We can already move on to Amazon Forecast. So I'm going to go back to the console in a new tab, and let's do this. Let's start building the pipeline in Amazon Forecast. All right, great. So let's do this. I'm going to go to the search bar. I'm going to enter Amazon Forecast. Here it is, a fully managed service for accurate time series prediction. And so the first step in Amazon Forecast is to create a dataset group. So let's create it, and then I will show you what it is exactly. What is a dataset group exactly? You will perfectly understand. It's like the whole dashboard of an Amazon Forecast project. So I'm going to show you. So let's do this. Let's click Create Dataset Group. First step is to give a name to the dataset group. So this time, not like Live Lab number 1, we can give very simple names because we won't have to distinguish types of instances or many services. So let's just give simple names like My Dataset Group. That will be completely fine. So My Dataset Group. And then second step is to choose a forecasting domain. So as you can see, AWS, Amazon Forecast, actually has some predefined frameworks for different time series applications. From retail, so this is a predefined domain for forecasting demand for a retailer. Custom, where you can do some more customization. Inventory planning, that's also a typical time series project. EC2 capacity, if you want to predict the EC2 capacity with some historical data of the EC2 capacity. Workforce, web traffic, forecast web traffic to a web property on a set of web properties, and metrics. And so, of course, what is the one of our situation, of our case study now?
Retail.
Absolutely. Retail, because of course we are predicting the sales of 2 items in a store. Therefore, the demand of items in a store. Therefore, that is retail. Okay, so retail and then next. Great, you have successfully created your dataset group, my dataset group. Okay, so now I know it takes you directly to this other page where you have to create the target time series dataset, but I just want to show you right now what is a dataset group, you know, what we've just created before. So what we're going to do is we're going to scroll down, we're going to cancel this. We're just canceling the dataset creation, not the dataset group. The dataset group is well created. And we're going to click View Dataset Groups. And I'm going to show you exactly what is a dataset group according to Amazon Forecast. So here we go. Here we're going to click My Dataset Group, the one we just created. And there you go. That's exactly the dataset group. You know, this dashboard here is exactly the dataset group where we will have to create several elements one after the other. First, the dataset, the target time series data. So basically it will consist of importing the data from S3, you know, the CSV file that we just uploaded in S3. Then the second step will be to train a predictor, and that's still part of the dataset group. Then once the predictor is trained, the next step will be to generate the forecasts. That's still part of the dataset group. And then we can explore some insights by exploring the explainability, but I will tell you a few more words about this when we reach a further step in this live lab, okay? So basically, that's the dataset group. All this dashboard is the dataset group, and the first step is to indeed import the target time series data. So let's do this. Let's click Import here. All right, and it takes you now to the same page that we just canceled 2 minutes ago. All right, so dataset name, that's the first step here. Let's give once again a simple dataset name like my dataset. Okay, that's completely fine. And then the second step is to decide the frequency of your data. And well, let's have a look at the data again. What is the frequency, of course, here?
Days.
Absolutely. You see, we have the sales for each day. That's January 1st, 2017, January 2nd, 2017, January 3rd, 2017, up to December 31st, 2017. So the frequency here is, of course, days, but note that you can also choose other frequencies. If you have time series that have frequencies by the minutes or by the hours, by the weeks, months, or year, well, you can also choose that. If you have a data set that's giving you the certain demand or, you know, the certain consumption of items every 3 months, well, you can choose this as well. You would choose months here and then 3. You see, so you can choose any frequency, the one that you have in your data. But for our data set right now, well, we have a daily frequency. And so we're going to choose, of course, 1 day. All right. Then the data schema, and that's very, very important. Remember when I was telling you that Amazon Forecast doesn't adapt to your data set, but you have to adapt to Amazon Forecast? Well, that's exactly what I'm talking about. As you can see in the data schema here, Amazon Forecast has 3 fixed attributes. You know, I cannot edit them. I cannot delete them. I cannot, delete or edit them. I can, however, change the order. That's fine. But they are here and they have to stay here. Okay. And so what are those attributes? The first one is the item ID. The second one is the timestamp. And the third one is the demand. And so now that's where I'm going to show you the other data set, the big data, to see how I had to adapt to Amazon Forecast. Okay, because going from big data to small data, okay, I cut some things. I cut the store attribute and I cut the years. I only kept 2017 and I only kept items 1 and 2. But there are also other things that I had to do in order to make this adapted to Amazon Forecast. So let's see what it is. So in the big data, we can see that the attributes are date, store, item, sales. And in Amazon Forecast, those 3 compulsory attributes that you have to keep for your dataset, that you have to have in your dataset, are item ID, timestamp, and demand. And so the first thing that I did, going from big data to small data, is to replace date here by timestamp, then item here by item ID, and then sales here by demand. Okay, that's what I had to do in order to adapt to the format expected by Amazon Forecast. But then that's not all. I also had to make the item ID a string, because actually the item ID here, the item was an integer. I made it a string on either a Google spreadsheet or Excel or numbers as you want. So I made it a string. And same, the sales here, as you can see, this is another integer. The type is an integer. I made it a float, because as you can see in Amazon Forecast, the attribute type of the demand attribute is a float. So that's why here you see it's 19.00, and in the big data it was, well, 13 because that's 2017 and that's 2013. Okay, so
A question.
that's what I had. Yes.
If we use the JSON schema, it says that specify attribute name and so on.
Yes.
Can we adapt it to our dataset?
No.
No.
Look, let's play with this. Let's actually keep item, date, and sales here, okay? So basically here, I'm gonna choose item. I'm gonna make it an integer, just like the big data dataset, right? I'm just putting things back like the big data dataset. So in the big data dataset, the timestamp here attribute is called date. And well, we can keep timestamp, that's fine. And here that was sales, okay? And sales were actually an integer, okay? So I did that in the JSON mode, okay? Now let's go back to the schema builder and look at what it does. Instead of replacing the 3 compulsory attributes here by the ones I just changed, it added 3 new ones. So you see, now it's a data set of 6 attributes, which doesn't make any sense, by the way, because there's the demand here, there are the sales here, the date here, the timestamp here, and the item. So you see, it doesn't work. Even if you change the original ones here, well, it will just add new ones, okay? Does that answer your question?
Yes, definitely.
Okay, great. So
Thank you.
You see, these are compulsory attributes. So now let me go back to how it was. Well, I just have to remove them actually. So that's very important to understand. Amazon Forecast can't adapt to your dataset. You have to adapt your dataset to Amazon Forecast. However, that applies only to those 3 attributes. Okay. For those 3 attributes only, you have to make your dataset like the format of Amazon Forecast. However, for the other attributes, let's say, we want to have the store here in Amazon Forecast. Well, that's okay. We just have to add a new attribute here, call it store, and then make it an integer. And that's another attribute, and that makes it like the big data dataset. All right? But we're not going to do that because, of course, we're going to use the small data dataset. Okay? Clear for everybody? So that's all good. However, we have to change this, of course, the timestamp format. Here it is. As you can see, the timestamp format is just the year followed by the month and followed by the day. So that's exactly what we have to choose here. We have to select this one because, of course, we don't have the hours, minutes, and seconds. So make sure to choose this as well. And there you go. Okay, great. Now let's move on to the next step, which is the dataset import details. So that's basically where we have to import the data from S3. So here we have to give a name to the dataset import, basically. And just to make it clear, well, let's call it my dataset import or whatever you want. It doesn't really matter, but there you go. Time zone, completely irrelevant because anyway, the time series frequency is days, so we don't need a specific time zone here. And then import file type CSV. Yes, the file we uploaded into S3 is a CSV file. And here, that's where we have to specify the location of our data in S3. And so we're going to click this button here, Browse S3, to find our dataset and therefore to import it in Amazon Forecast. So that's the bucket we just created, bucket for Amazon Forecast. So let's go inside, and then we're going to select here the dataset we uploaded into S3, demand forecasting.csv. We click choose, and all good. We have the data well selected. And now, very important, remember that whenever we use an AWS service that will either read or write in S3, well, we have to give permissions to this AWS service. And how to give permissions to an AWS service? With IAM roles. Okay, IAM roles. So now we have to create an IAM role for Amazon Forecast in order to grant Amazon Forecast access to S3 in order to read or write. And actually, because we're going to do some exports at the end, it will also be about writing. Okay, we have to give the permission to read into S3 in order to import the dataset, but also to write into S3 in order to export the predictions. Okay. And good news, this time, as opposed to Live Lab number 1, we don't have to create a role in IAM. We can just directly create a role here by clicking here, create a new role. And this will create a role that will grant Amazon Forecast access to any S3 bucket, or we can actually specify the bucket we just created. But just to make things simpler, let's just select any S3 bucket, and then we click create role. And there you go. Success, you create an IAM role that gives Amazon Forecast permissions to read and write into S3. Perfect. Okay, so all good for everyone? Are you ready to start importing the data?
Ready?
3.
Let's
Okay,
get
great.
going.
Yeah, let's do this. 3, 2, 1, go. All right, and now it's going to import the data. And this is going to take a little while. So in the meantime, we can just, this is going to be fast because of course we choose the small data, but this is going to take 2 or 3 minutes. So in the meantime, we can just, there you go. It's active. Actually, I want to show you something else now. Now that we created the dataset group and the data, well, we have here the whole dataset group features. So the dashboard, the dataset we just uploaded, which is this one, imported, in Amazon Forecast. And indeed, that is in the retail domain. And if we go inside the dataset, we can see some important features. Well, first, the timestamp format. Okay, good. But also the number of observations, 730, just like in our dataset. The number of unique entries, for the demand, 730, 93 unique number of sales, basically. Then for the item ID, of course, we only have 2 items, item number 1 and item number 2, with 730. And then the timestamp, 730 entries, which corresponds to the number of observations. 365 unique entries, of course, because there is only 1 year. And schema, that's the JSON, and tags. Okay. So you see you have the different features and information about your dataset. So now let's go to the dashboard and let's move on to the next step, the most exciting one. Well, no, actually the most exciting one will be to generate the forecast, but an exciting one, which is to train the predictor, which will be a time series analysis model. So let's do this. Let's click start. Okay, predictor name. Let's give it a simple name, my predictor. Then forecast frequency. Okay, so of course here we want to say 1 day because in the historical data, the frequency is 1 day. But we could choose, for example, to give the sales predictions every 2 days. And in that case, we would choose 2 days here. Okay, but of course we would like to predict the sales for every day of the next month because indeed, let's go back to the data set. In the big data, we have the historical data from 2013 to 2017. So here we could ask to run the predictions for the whole next year of 2018. But now, of course, for the small data, we only have the year of 2017. So it would make more sense to run the predictions for the whole next month, the whole month of January 2018. And that's what we're going to do. So going back here, we're going to choose a frequency of 1 day and a forecast horizon of 31 days because we're going to predict the sales of the whole month of January 2018, meaning all the days of January 2018. And in January, you have 31 days. And so that's why I'm choosing a forecast horizon of 31 days. So that's what we have to configure. Now, very important, the forecast quantiles. So everybody know what a quantile is? Okay, so I'm going to explain. Basically, the time series prediction model that we're about to build is going to be trained on the historical data and is going to learn how to run these predictions based on a distribution. So basically, it's going to build for each data point a distribution where you have in the x-axis the values of the predictions and in the y-axis the probability of the prediction. And the quantiles are going to be, for example, if you take the quantile of 0.50, well, that's going to be the median. And actually, most of the time, the distribution in a forecast time series prediction model is going to follow a normal distribution. And therefore, the median, if it's exactly a normal distribution, the median is going to be the mean. Okay. Therefore, here we're not going to keep the 0.10 quantiles or 0.90 quantiles. We're going to remove them. We're going to keep the 0.50 quantile, which is the median, and we're going to add another one, which is going to be the mean. So I'm going to put the mean here for the first quantile and the median for the second quantile. Actually, I have to write it like that, 0.50. Okay, so 0.50, whatever the distribution is the median. Okay, and you're going to see at the end that when we export the forecast, well, we're going to have a mean very close to the median. I just want to show you this so that we realize that indeed the predictions are based on a distribution, and that's how the model is trained to make the predictions for the next year. Okay for everybody? Okay, good. So that's the forecast quantiles. Let's keep this. Then, interesting here, predictor configuration, optimization metric. So here, that's where we choose an optimization metric. And we have the choice between WAPE, RMSE, MAPE, and MMSE. So the most common one is the RMSE, root mean squared error. But I would recommend to keep the default one because indeed, if we click info here, Well, by default, Forecast will create an optimized predictor by selecting model with the lowest average losses over the specified forecast types. You can also optimize your predictor with one of the following accuracy metrics: average weighted quantile loss, weighted absolute percentage error, root mean squared error, mean absolute percentage error, and mean absolute scaled error. But let's keep the default one because this will run optimized predictions. Okay, then explainability. Do we want to activate explainability? Here, for the small data, this won't be necessary. Why is that? Because the explainability will give you an analysis of your different attributes by showing which ones have the most impact on the demand, which you want to predict, okay? And here, since in the small data, well, we only have the item ID attribute, the time step, and the demand, there are not really other attributes here, in other columns that could, help in predicting the demands. We don't have that. In big data, we have that with the store. Maybe, the store has some impact on the sales of the items, in which case here, for example, in the big data, we would definitely activate the explainability in order to understand whether the stores have some impacts on the sales of the items. But here for the small data, we don't have the stores. I removed the attribute. And so we're not going to activate the explainability. But if you click info here, well, you will see that if you activate the explainability, well, you will get impact scores for the different attributes of your data set. And I really recommend to activate if your data set have other attributes besides the timestamp and the item ID, like the store in big data. Okay, so the values of the score range from 0 to 1, and of course the larger value, meaning the closer to 1, implies a more significant impact on forecast values. So if, for example, if we're working on the big data and we're keeping the store attribute and we activate the explainability, well, at the end we will have an impact score for the store's attribute. And if this impact score is, let's say, 90%, well, that means that the store has a high impact on the demand that we want to predict. However, if it has, for example, 0.1, well, then the store doesn't have much impact or much predictability on the demand, the sales of the item. So that's what the explainability is about. But as we said, we're working on small data, so we're not going to activate it. And then you can choose if you want to activate predictor monitoring. That's just in order to see how the predictor accuracy is changing as time progresses. But it's okay, we don't need to do that unless you want to see how the scores is improving over time. Well, you can activate predictor monitoring, but for now, I'm not going to activate it. Then input data configuration. So activate holidays. That depends if you think that in your data, in your time series, well, the holidays have some high impact on the demand, on what you want to predict. Here, for the demand of some items in a store, I don't think the holidays will have much impact. Actually, maybe on holidays people leave, so maybe they get less into the stores. At the same time, you have some tourists coming. So I don't know, you can choose to activate holidays. I'm going to choose not to activate it because anyway, I tried it before and we're going to get some good results. All right, so that's all you have to configure when you train your predictor. Make sure to choose a frequency of 1 day, a forecast horizon of 31 days, just the two quantiles, the mean and the median, the default optimization metric, or the RMSE if you want, and no holidays for the input data configuration. Is everybody ready to create and train the predictor? Let's click create. Great. Okay, by the way, not to confuse, now we just clicked create predictor and you see now train predictor. Don't confuse that we have to train the predictor we just created. No, when we clicked create predictor, it not only creates the predictor, but it also trains the predictor. So if you click train predictor here, it is just in order to create a new predictor, create and train a new predictor. So we won't do that. Instead, we're going to click view predictors. And as you can see, that's your predictor, the one we just created, and the create is in progress. And don't worry, it says that 2 hours and 5 minutes are remaining, but it's much less than that. Each time they say this long time, but actually it will be ready way before. It will be ready in less than an hour. So I'm going to go to my other account, Live Lab number 2 Amazon Forecast, where my predictor is trained. It's trained already, and then I didn't do the other steps. As you can see in my dataset group, I have the data imported, just like we did. I have my predictors that is trained, but I haven't started yet the forecast generation, and that's exactly the next step. So now let's do this. Well, I'm going to do it alone, but here we go. Let's start the forecast generation. Okay, forecast details. So first we have to give a name to our forecast. So I'm going to call it my forecast. Then we have to choose a predictor, and we're going to, of course, choose the one that we just created and trained, my predictor. Then forecast quantiles. So that's an optional parameter. But if you don't enter anything, it's going to automatically take the forecast quantiles we took before when creating the predictor. I think it's written somewhere. Yeah. The default quantiles are what you specified during predictor creation. So it's going to take them in automatically. You don't have to specify again mean and the median 0.50. However, if you change your mind and you want some other quantiles, well, here's your chance to enter them now. Okay. Now, next step, items for generating forecasts. All items, selected items, we're going to choose all items. That's good. And so here we go. We're going to click start. That's all we have to do, basically. We just have to choose our predictor, and it's going to generate the forecasts on the dataset. And considering that when creating the predictor, we chose the horizon of the predictions, the horizon of the forecast, which was, remember, 31 days. Well, that means it's going to generate the forecast for every day in January 2018, the next 31 days after the last day of the historical data. Okay, so here we go. Let's start. My forecast, create pending, and now it's just going to take a couple minutes, but it's going to be very fast because, of course, the model is already trained, and it's just going to generate the forecast for the next 31 days after the last day of the historical data, meaning after December 31st, 2017. So it's going to generate the forecast of the sales of items 1 and 2 for every day in January 2018, from January 1st to January 31st, 2018. Oh, there you go. See, I was telling you. And now active. Okay, great. And that's the same for the training, by the way. I don't know where you are right now with the training, but it's going to do exactly the same thing. It's going to say, it's ready in 1 hour and 15 minutes, and the next minute it will be active. So great. Let me know if, by the way, any one of you has the trained model already. So now let's go to, not here, my forecast, because it will just give you the infos of your forecast, like the insights, exports, and all. So what we have to do is go back to the dashboard of our dataset group. And here, well, we don't have to do create a forecast because that would be to create another forecast. But if you want to run the predictions with the forecast that you just generated, well, you have to click this, query forecast. And then after that, I'll show you, of course, how to export the predictions. Okay, so for the forecast type, of course, we're going to choose the forecast that we just created, my forecast. Then for the start date of the forecast, well, we're going to choose, of course, the next day after the last day of the historical data. The last day of the historical data is 31st of December 2017. So the start date will be here. The start date will be here, 2018, 0101, 1st of January 2018. So that's the start date. And then, oh no, actually, sorry, this is the start date for the historical demand you want to view. So this is more 2017 then. We would like to display the data, the whole historical data, and the predictions after that. I think that would be the nicest way to visualize it. And then the end date, this is the end date. This time, yeah, this is the end date for the forecast that you want to view. So remember the horizon that we chose, 31 days after the last day of the historical data. Therefore, the last day is January 31st, 2018. And so here we're going to enter 2018, 01, 31. Okay?
Or better, I think it would be better 2018 0201 because we have 0 hours, so we'll get the
yeah, okay,
31st day.
Yeah, good point. Let's see if anyway AWS generates some error because I know we can't go after the horizon. So let's see, 01, like that, huh? Okay, now choose the keys you want to use to filter your forecast. Okay, so basically here we have to enter the value of the item of which we want to see the predictions. And well, in the data set, we only have 2 items, item number 1 and item number 2. So here, according to you, which value do we have to enter?
Either 1 or 2.
Exactly. So let's start with 1. Let's start with the first item, okay? And let's see if it allows us to get the forecast or if it will generate some errors, either because we are starting too early in the historical data or because we are finishing too late after the horizon. Let's try get forecast. There we go. Our first error of this live lab number 2. Great. I would be kind of disappointed if we didn't have any error. So invalid historical target field value start date provided. Okay, so it's a problem with the start date. The start date must not be before 2017 December 01. Oh, okay. So interestingly, when we visualize the data using the query feature, we can't visualize the whole historical data. We can only visualize, I think it's just one horizon. We cannot visualize before one horizon of the historical data. Therefore, since we chose 31 days as the horizon, that's why we cannot start a date before 2017 12/01. Okay, no problem. Here, I'm going to replace 01 by 12. Okay, and then it says the end date must not be after 2018-01-31. Yeah, I expected that because 0201 is actually right after the horizon. So here we have to choose 01-31.
Yeah, 0131. And maybe you can add the time, 23 hours, 59 minutes.
Yeah, good point. Good point. All right, and 0002. So now it should be good.
Let's go.
Get forecast. Now it works. Wait, why is it only showing the historical demand?
There's an error up top.
Invalid yeah, thank you. Thank you so much. Invalid forecast query end date provided. The end date must not be after 01. Oh, 000. So no, we cannot put 23, 59, 59. We have to put 00000.
Okay.
So now
that
hopefully
maybe means that the end date that we added in the horizon was not inclusive of the last day.
Yeah,
maybe
exactly.
We had to add one more day.
Yeah, we should have one more day, like 32 days, you mean, right?
Yep.
Yeah, okay. So now hopefully by fixing this, hopefully it will show it the forecast, because now it only showed us the last months of the historical data. So now let's see, get forecast. There we go. Now we have the predictions. Woo! Okay, so here we have the historical data, well, the last months of the historical data. And here we have the predictions for each day of January 2018. Okay, right? If I remove the demand, well, that's the prediction. And actually, as I was telling you, it's very, very, very close to a normal distribution, right? As you can see, we don't see exactly, but the mean forecast and the P50, meaning the median forecast, excuse me, that was stupid, are very close to each other. See? Here, for example, the median forecast is 17.62 and the mean forecast is 17.71. So you see how I was telling you that the distribution on which the time series prediction model bases its predictions is very, very, very close to a normal distribution. Basically, it's almost a normal distribution, and therefore, the mean is almost equal to the median. So there you go. That's the historical demand of December 2017, and that's the predicted sales of January 2018 for each day of January 2018. Okay? And so, for example, for January 22nd of 2018, well, the predicted sale is 16.6. Well, let's say 17 items sold that day of the first item. Now, let's have a look at the second item, actually. Let's move on to item 2. So here, very simply, we just have to enter 2 here for the value and get the forecast. Oops, yeah. And very similar curve for the item 2, but for different values. Here's different values from 40 to 60. All right, so that's the visualization dashboard of Amazon Forecast, which allows you to query some forecasts. But then you can also export your forecast, and to do so, I'm going to show it to you. Well, you can either go to your dataset group. Now, actually, from the dataset group, you can only query the forecast or create a new forecast. But if you want to export the forecast, you need to go there on left to forecast. Then you select this, and then you click Create Forecast Export. So would you like to do this? Would you like to export the forecast in S3? Of course, it will be in S3. Let's see. Let's see how we do it. So export name, let's call it my forecast export. Okay, my forecast export. IAM role, we're going to choose, of course, the role that was created to give Amazon Forecast permissions to this time write into S3, right? The first time it was to read into S3 to import the data, but now it's going to be to write into S3, the permission, in order to give the export. KMS optional, okay. Export file type, yeah, we would like to have a CSV file because anyway, we'll download it and we'll open it with a text editor. And S3 forecast export location, well, very simply, we're just going to export that in the bucket we created, the same bucket as where we have our input data, meaning this one, okay? So let's click choose and let's start the export. And now the forecast export for my forecast export has started. So now let's go into S3. Where is S3? Yeah, S3. I'm going to open S3 in a new tab. Bucket for Amazon Forecast. Let's see if we already have the exported data. It's in process. So that's the input data. And check means that the forecast is being exported. And soon, if we refresh, we will see success. And once we see success, it will be exported. So yeah, let's just wait for... it's not long at all. It will even be faster than when we generated the forecast. The forecast is already generated. Now it's just exporting it into S3, and it will be ready very soon. if we go back there, my forecast, export, my forecast, create in progress. Yeah, that's where we can see the status of the export creation. So now it's in progress. Let's go back to S3 and let's refresh here. It will be ready in any minute.
Yeah, it will definitely not take so long as the forecast.
Yeah. As the forecast is done already. It's just some exports.
I wanted
there
to
you
share
go.
that. Okay, it's go. It's done. Okay.
Success.
Good.
And these are your two exports for item number 1 and item number 2. Okay, so yeah, we have the export. Actually, if we refresh this, it should be done. But there you go. In S3, we have the two exports for item number 1 and item number 2. So let's download them. Actions. Wait, where is download? Download? Why can't I download them? Wait, let's refresh. Maybe it's because... okay, we can just download one at a time for some reason. Okay, so download, or maybe that's because this one is completely exported and the other one is not ready. Okay, so live lab number 2, let's export it in the small data folder. Save. Okay, and now can we download the other one? Yes. Okay, but we can't download the two of... No. Okay, so just one at a time. Yes. Good. Now let's go back and let's have a look at them. Live lab number 2, small data, and here are our two exports. Well, actually, I can open them like that. Sublime text, open, small data, and open. All right. So that's the forecast of item number 1, and that's the forecast of item number 2. So as we see, we have all the values. Well, we have the mean first, and then the median, and as you see, it's very close, but not exactly close. So that's not exactly a normal distribution. But yes, we have all the mean and median quantile predictions for all the days of January 2018 for item number 1. And then same for item number 2, we have all the mean and median quantiles prediction for all the days of 2018 from January 1st to January 31st for item number 2. There you go. And that's it, actually. That's the point I wanted to reach today with Amazon Forecast. Of course, then remember, if you have some other attributes, there is this other, this final step in the dashboard of your dataset group, which is the explainability. So if you had several attributes and you activated the explainability while training your predictor, well, that's where you would explore the explainability and also the what if analysis. Okay, interesting. So there you go. Now we're going to do the cleanup. It's very important that I include this in this recording, because once your model is trained, I guess you're going to follow with the recording. Well, you don't have to, but the other ones will follow. And so it's very important that I do the cleanup. So are you all ready for me to do the cleanup, or do you have questions about what just happened with this forecast export?
Ready.
Ready.
Let's
Okay.
go.
Let's go. Let's do this. So the cleanup in Amazon Forecast follows a bottom-up approach. It's very easy. You have to start from the bottom and make your way up to the top to delete everything. So basically, we have to start by deleting the forecast. Here we go. My forecast. Delete. Delete. And delete. And there you go. It's deleted. Perfect. Now we're going to delete the predictor. My predictor. Delete, 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 delete pending. Oh, by the way, you have the option to retrain your model. Interesting. I had not seen this before. Yeah, there is a question.
Now, my question is, when deleting this, S3 and the, the forecast have nothing to do with it, right? So you can actually do the S3.
Oh, yeah. You could do the S3 deletion first. Absolutely right. Yeah, you could delete the exports and the input data, because now it's separate, And actually,
Yes.
That's a good point. Wow. See, there you go. Predictor deleted successfully. Empty predictor. We don't have any more predictors. Good. So now, lastly, we're going to remove the dataset. Well, we have two more things to delete, which is the dataset first and then the dataset group. So here we go with the dataset. Don't pay attention to this. This is not created. I don't know why it's here. Yeah. It's because here in the dashboard, you have the option to import your dataset, of course, but also some metadata data or some related time series data, but we haven't done it. This was not part of the original data, so all good. So yeah, back in the dataset, we select the dataset, we click delete, we enter delete here, and we delete the dataset. Your dataset, my dataset, and its child resources is deleting. This may take a few minutes. So in the meantime, we're going to delete S3. So two ways to do this. Either you select everything here and you click delete, Or the second way is you go to your bucket, you select the bucket, you click empty, and then you enter permanently delete here. And you will see that it will empty with absolutely no problem because it's no longer attached to Amazon Forecast. So exit, and now we can delete the bucket. So here we go. We copy the name of the bucket. We enter it here, and we click delete bucket. Okay, all good in S3. Now, if you want, we can remove the role in IAM and the policy also, because actually, when you create a role, there's either administrator access policy attached to the role or a specific policy that was created just for the role. So actually, that's the case here. I can recognize this because usually there's 0 here because this is a number of customer build policies. So let's go to the roles first, delete the Amazon Forecast execution role that was created for Amazon Forecast. So delete. We copy the name of the role, paste it here, and delete. Deleting role, and role deleted successfully. Perfect. Now let's delete the policy that was created for the role. There you go. Amazon customer managed. You see, customer managed policy. So we select it, actions, delete. We enter the name of the policy. By the way, this is completely optional. It's just to do a full, thorough cleanup, but the policies, of course, are not going to charge you. Delete. Deleting policy. Policy deleted. All good for IAM. Great. This was all good for S3. And this is normal. This is just that the dataset that was here cannot be found. Not found. That means it was deleted. So all good. If we refresh, yeah, we see not created. All good. And so now, final step, we are going to delete the dataset group. So we have to go back to dataset groups here and select it. By the way, I just want to show you something quickly. If we go back to our dataset group, well, we see that everything here that we had is no longer there. Huh? Everything is deleted. So yeah, let's go back to dataset groups here. Let's select the dataset group, delete, and cleanup done. I know this may take a few minutes. Sorry, I thought it would be instant because everything was removed anyway. It should take really a few seconds to delete the dataset group. Amazon there you go. Now it's deleted. You see, if I click here, everything is gone. I can't expand it to see the dataset group, and I have to create a new one. So there you go. Live lab number 2 done. Congratulations for attending until the end. Actually, not many people attended, but you all stayed until the end. So thank you. Thank you for attending. I hope you liked it. I hope you learned from this, and I hope that gives you the motivation to use it for the next time series data that you will have.
It was awesome. Thank you.
Thanks. Yeah, you're welcome, Cassie. Thank you.
Thank you, Hadelin.
It was a lot of fun.
Thank you very much. I was so glad to give you this live lab number 2. The recording will be published tomorrow. So enjoy, and let me know if you have any issues once your models are trained, or if you have any issues generating the forecast. Of course, feel free to reach out. Bye-bye. Thank you again.
Bye-bye.
Bye. Have a good one.
You too. Take care.